Good day everyone, we are Group 7 and we'll be doing the experiment number 9, which is the sieving and plastic limit by Atterberg method. So the plastic limit is the water content of the change from a plastic to a semi-solid state. This test involves repeatedly rolling a soil sample into a thread until it reaches a point where it crumbles. So the reference standard following this experiment is the ASTM D4318. This is the standard test method for liquid limit, plastic limit, and plasticity index of soils. So the objective for this experiment is to determine the plastic limit of soil through the Atterberg method. The materials and equipment to be used are the following.
So now we are going to weigh the container for the experiment.
So now we are weighing 3 soil samples with 25 grams per sample. We are just going to minus the mass of the container from the soil.
So now we're gonna mix the soil and water. First 10 ml. We'll be adding 10 ml to achieve the soil consistency.
Now we're just mixing all the 3 samples simultaneously with the soil and the preferred water for it to reach its consistency.
So now we're gonna roll the soil into an ellipsoidal mass until it reaches 3.2 mm diameter.
So now we are cutting the needed 3.2 diameter soil sample into little parts or pieces, and then we'll be forming it again into an ellipsoidal mass again, and then we'll be doing this process all over again until the soil sample breaks already.
So we are weighing the sample 1, 2, so now we'll be needing the sample 2 into a ellipsoidal mass.
Sige pala, drop. Sample 2.
Since we are done with the soil sample 2, we are going to start kneading the sample 3 into an ellipsoidal mass until 3.2 mm diameter. So now we are going to cut the soil sample 3 into several pieces.
So now we are done weighing the sample 1, and it is at least 6 grams. I think this is 10 grams already. And then we'll be proceeding to sample 2, this one. So we'll be putting all the samples together lang sa oven. So first we'll be proceeding to this sample 2.
So now we will be weighing the sample 3.
So now Sir Leon is putting all the samples in.
So the reference standard that we used for our experiment is the ASTM D4318, or also known as the standard test method for liquid limit, plastic limit, and plasticity index of soils. So now we will talk about the results of our experiment. Presented in the table on the screen are the data that we have gathered and the results of our experiment. We only have one data sheet for this experiment that consists of 7 types of data. First, we have the mass of container, which is the M1, the value of added water in milliliter. Third is the mass of container plus wet soil, which is the M2. Fourth is the mass of the container plus dry soil, which is the M3. Fifth is the mass of water, which can be computed by subtracting M3 from M2. Sixth is the mass of dried soil, which can be computed by subtracting M1 from M3. And lastly, we have the water content, which can be solved using the formula M2 minus M3 over M3 minus M1 times 100 to get the percentage. On the lower right of the screen, you can see the formula used in solving for the water content. First, we have the sample 1, which is 33.4 grams minus 29.6 grams over 29.6 grams minus 23.4 grams times 100%, which yielded to 61.3%. For the sample 2, it yielded into 47.1% of water, and for the sample 3, we have 58.7% of water. From that, we have used the values of the water content to get the plastic limit. We have averaged the 3 values, and the plastic limit for our experiment is 55.7%. We have reached these results by following the reference standard of ASTM D4318. From that, we have followed the diameter of the rolling soil should be in 3.2 mm and should be rolled within 2 minutes. We also had 10 grams of soil per sample since the reference standard should be at least 6 grams. And lastly, what would be the importance of plastic limit? The importance of plastic limit test of soil are the following. First, the value of the plastic limit is used to classify the fine-grained soils and evaluating the activities of clayey soils. Second, it indicates the toughness index of soil. Third, its results give an idea on the consistency of soil. And fourth, it is used to predict the consolidation properties of soil while computing the settlement and bearing capacity of the soil. This is very important, especially when planning buildings and creating plans for construction. And that's all for this video. Thank you for watching.